We're on page 163 of your student journal, covering independent and dependent events. So, I mean, pretty much, if you think about just the definitions of these words, independent and dependent, right? So, independent is something that stands apart. If you're independent from your parents, that means you pay your own bills and you take care of your own stuff. As of now, you guys are dependents. That means you depend on someone else to pay your bills and feed you and such. Generally, at least, and that's the way these work as well. So independent events are events. Let's see here. Can I write? Okay, events. Why? Let me write. Events that pretty much are completely separate, or they don't impact each other. Events whose probabilities, probabilities do not impact each other. So that's it for independent events. And so for dependent events, then they are events whose probabilities do impact each other. And lastly, conditional probability are probabilities that an event occurs given another event. So I know it sounds kind of dicey, but when I give you examples, hopefully they clear up. So moving on, let's get into some examples. So let's get into probabilities of independent events. So one thing that I thought of was thinking about your address. So your house or your apartment or whatever has either 3 or 4 numbers. So let's think about that. All right. Let's say I was guessing at your address, and so the numbers we have to pick from are what? 0, 1, 2, 3, 4, so on and so forth, all the way up until 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 possibilities for if I'm just guessing the first number in your address, right? And so no matter what number it is, let's say our address number is 426, or no, that's just all even numbers. Let's say it's 421, but I don't know that, and I'm trying to guess it. So out of these 10 numbers, what are my chances of guessing a 4? Right, and there's only one 4. But how many possibilities are there? So there's 10, right? And next, it's okay, 4, 2. What are my chances of picking out a 2? Well, there's only 1, 2, and there's 10 numbers. And lastly, what is my chance of picking a 1? 1 out of 10. So my chances, or my probability of picking all 3 numbers correctly is 1, because 1 times 1 times 1, over 10 times 10 times 10. So 10 times 10 is 100, 100 times 10 is 1,000. And that is assuming that we can repeat numbers. So, let's say instead of 421, it could be 444, right? Well, if it was 4, my probability is 1 out of 10. The second 4 is also 1 out of 10, and the third 4 is also 1 out of 10. That's if I cannot repeat this one is if I can repeat numbers. So, all the numbers are still in there, so they're independent events, because if I pick a 4 the first time around, that doesn't impact anything. The next number could be a 4, or it could be something besides a 4. So this is independent events. So I multiply the probabilities together. Moving on to an example of dependent events, then let's set up a different example, and say that let's set up the situation real quick. So there are 8 marbles in a bag, 3 red, 4 blue, and 1 green. So what is the probability of picking a red then a green? So first, the first one, you might think like, okay, well, I got to think about the total number of marbles there are. So 3, 4, 1, that makes 8 marbles. So my probability of picking a red first is, how many reds do I have? It's 3, right? So I go ahead and take out a marble, and I don't know if it's red or not, but I'll go ahead and pick it. Then a green. And one important thing that I forgot to set up is that after each pick, I do not replace the marble. So that means I pick it and then I keep it taken out, right? So then you think, okay, well, I have one green out of. Now, if I've already picked out a marble, then are there 8 marbles left? And the answer is no. So it's 3 over 8, so it's red out of all possibilities, 3 reds out of all possibilities, and then the greens out of the separate number of possibilities is 7 if I take out the marble, if I take out the first one. So it's 3 over 8 times 7 is 56. But if we were to change it and say, okay, well, so this is an example of dependent events. After each pick, I do not replace the marble. But if I replaced it and said after each pick I do replace the marble, then it would be 3/8 times, how many greens are there? So I go ahead and I pick out the marble, check if it's red, and then I put it back. So after I put it back, there are still 8 marbles, right? So in one case, we have 3 out of 64. And this is when they're independent events, if I replace them. But if I take it out, then it is dependent. And because the possibilities, because the total number of possibilities change. So to sum it up, you have independent events where, it's kind of a free-for-all, like nothing impacts another thing. And then you have dependent events where the first thing does impact the second thing that we are like, counting or checking or whatever. Before I do this, so these honestly 1 and 2 are mostly just the reasoning. Like, can you tell whether or not something impacts something else? If it does impact, then they are dependent. If they are completely separate, then they are independent. Here, same thing. It says letters can be used more than once. That's the key to this problem. And then for number 4, the key is that letters cannot be used more than once. I'm not doing these because you only have like 5 problems to practice, so it would be kind of a sham if I showed you. That's why I wanted to do those separate examples earlier. The total shows the number of male and female college students who played collegiate basketball and collegiate soccer. That means they played soccer in college or basketball in college. The keys here is find the probability that a randomly selected collegiate soccer player is female. But we only want to look in the category of collegiate soccer players. So you'll check your answer with me, but I'm telling you this is the key. This is the category you're interested in, collegiate soccer players. What am I saying? I'm saying you will not total everything. Because if it wanted you to total everything, then it would just say, oh, find the problem that a randomly selected student. Or find the probability that a randomly selected athlete, or whatever the case is. So for this problem, just be careful, read it carefully, and then check your answer with me. But you guys have 5 problems. Kind of just get your toes wet, and have a good understanding of like what independent and dependent means.